Hello everyone, welcome to my channel, and today we are going to deal with another new topic in set theory, and that is Cartesian product. You must have heard a very important concept in geometry, that is Cartesian graph, which is a graph between x and y. If you are trying to represent any of the point, you will need to mention it using a ordered pair. It means this is actually a cross product of R into R. This is a real plane containing all so many points. This is actually the cross product of two real number sets, and both are the same. Now coming to the simpler concept, that is the Cartesian product of two sets A and B. It can be either finite or infinite, all ordered pairs where the first element belong to set A and second element belongs to B, and Cartesian product is denoted by A cross B and can be formally written as C. It can be defined as A cross B is equal to elements which are all ordered pairs of the form A comma B, and the first element belongs to A and the second element belong to B, and that's what the definition is saying in this. Now coming to the first example, let's imagine that there are two sets. Okay, there are two sets. This is set A and this is set B. Whenever you are doing the cross product, you should make sure that you have got ordered pairs. This is one order pair, second order pair, third ordered pair, and the fourth ordered pair. Set A is containing two elements 0 and 1. B is containing 2 and 3. Now whenever you are writing, I can write this ordered pair 0 and 2. I can write 0 and 3. I can write 1 and 2. I can write 1 and 3. And so we are going to list all the possibilities of A comma B from both the sets. And if you take next example, this is A is equal to a set containing only one element, B is equal to set containing two elements. Similarly, if it is A and if it is B, which is containing 2 and 3. Now, if you take the cross product of 1 and 2 comma 3, we have got in this way 1 comma 2 and 1 comma 3. If you see clearly that the number of elements in A cross B is equal to number of elements in A into number of elements in B. Let's see in this case how many elements we have got. The formula was number of elements in A into number of elements in B. Total number of elements in A cross B is equal to this much. What is the number of elements in A? It is 1, 2. So it is 2 into number of elements in B. It is 2. And this is equal to 4. See, this is 1, 2, 3, 4. If you see in this case also, we have got A cross B is equal to number of elements in A into number of elements in B, and this is equal to number of elements in A is 1 into number of elements in B is 2, and this is equal to 2, and that's why we have got 1, 2. I hope this one is clear. Now coming to the last example. This example is similar. You can try this one and find the cross product A cross B. And now coming to the note, they are very important concepts in the cross product. Whenever you have got A is equal to 5 or B is equal to 5, for example, A is equal to A comma B and B is equal to a empty set. If you take in this case, if you take A cross B, we always have a empty set or is equal to 5. That's what is said by the first thing. Now coming to the second note, that A is equal to B, we have got, if whenever A is equal to 1 comma 2, then we have got A cross A is equal to, there will be 4 elements. You can try listing them. Okay. And just before some time I explained about the Cartesian product, which will be having infinitely many numbers on the y-axis, on the x-axis, and this is actually r cross r. You can mention it as r square also, according to the second node. Coming to the third node, now just we have taken this example. Okay, let's take this example. A cross B is equal to, we had 1 comma 2 and 1 comma 3. I think there is no doubt in this. Let's try writing B cross A. This is 2 comma 3 cross 1. In this case, first element should be from B. That's why it will be 2 comma 1 and then 3 comma 1. Remember one thing, 1 comma 2 is never equal to 2 comma 1, and therefore we have A cross B is not equal to B cross A. In the set, if you are rearranging the elements, this is written here and this is written here, it doesn't matter, but in ordered pairs the sequence must be followed. Oh, this is clear. Now coming to the next node, that is the number of elements in A cross B is equal to this, and this is equal to A cross B is equal to B cross A is equal to A into B. Just now I have given example. You can rewind the video and check once. Now coming to the sixth point. If A is infinite and B is infinite, if both are infinite, actually if one of them is infinite, then the cross product is infinite. Let's take an example. 1 is equal to 1, 2, 3 and so on, and B is equal to A comma B. In this case, if you are taking A cross B is equal to, I got 1 comma A, 1 comma B, 2 comma A and 2 comma B, 3 comma A, 3 comma B and so on. So it should be OR. If A is infinite, B is infinite, then A cross B is also infinite. And in the next video, we'll be looking at some of the examples related to cross product. Thank you.